Permafrost thaw and methane emissions. As Arctic temperature increases, the perennially frozen ground known as permafrost is beginning to melt. This thaw creates thermokarst lakes. These lakes occur when thawing soil causes the ground ice to melt, making the surface buckle and creating divots and craters. These divots fill up with rain and snow runoff and amplify the permafrost thaw underneath them. This process releases large amounts of ancient greenhouse gases that were once frozen in the soil. It's estimated that the Arctic soil holds twice the carbon than in the atmosphere. Not only that, but the thaw also activates frozen microbes that are able to break down the carbon in the soil and turn it into methane and carbon dioxide. While much of the released greenhouse gases from the microbes is compensated for due to the fact that the increase in temperature also means increase in plant growth, the plants only take the carbon dioxide out of the air, leaving the methane in the atmosphere. The majority of the gases being released are made up of methane, a highly flammable gas that is 84 times better at trapping heat than CO2. This release of greenhouse gases into the atmosphere has not been taken into account in many climate predictions because the lakes are rather small and scattered. But scientists are beginning to realize their importance. According to a NASA scientist, Walter Anthony, by the middle to the end of the century, the permafrost carbon feedback should be about equivalent to the second strongest source of anthropogenic source of greenhouse gases, which is land use change. As you can see, this issue is very important to consider due to its strong impact on the positive climate cycle. But it also affects Arctic peoples and the fragile ecosystems found there. The creation of these lakes destroys habitats, converting entire ecosystems into fens and bogs. When it comes to dealing with the effects of climate change, the Arctic is the least resilient region in the world. Abrupt changes in ecosystems will greatly impact the already threatened species that rely on them. An example of this is the fragile birch forest, predicted to be completely eliminated by the end of the 21st century, if permafrost thaw continues to melt. Arctic communities are also being affected, with melting permafrost rivers causing entire towns to be moved. Despite its vast impacts, there is little that can be done to directly mitigate the impacts of melting permafrost. Any initiative, however, to combat climate change can contribute and slow the positive feedback loop. Things like Canada's carbon tax, climate protests, and even everyday action can help slow and prevent these effects. Now that you know all of this, the question remains, what are you going to do about it?